Hello guys, welcome back. This is Krishna and welcome to AI Martians. So, in the last session, I talked about MAE, mean absolute error. So, that's a loss function, and I told you like I will train a model on a data set using MAE. So, MAE I'm going to use now. There's a loss function, and I will train a model. I also try to get a new data set having a lot of features, like it has four features and one target. So it's a kind of salary data set, but now this time the data is little bit higher as compared to the last one. Two data set now, but one having lower feature and data samples, whereas the other contain a higher feature and higher samples. So let's train a model and I will tell you like how it work, like MSC, how it work. I will tell you about it. So let's go to Google Colab Sheet and we will try to understand like how to use it. It's not a big deal to use MSC. It's a simple terminology which I have to use in a loss, okay? But I want to show you like how we will train from the scratch, all right? So I will also show you like how to download the data, how to put it into Drive, okay? And how to read that data. Further, you have to use that data for scaling, breaking down the data into two parts like training data set and testing data set. Then you have to train a model. You have to pass that validation data like testing data for validation in each epoch. I will tell you everything. So let's go to Google Colab Sheet. So you have to simply download that data from Kaggle and you have to use it. Now let's move ahead and we'll see like how we will proceed in this. So first of all, we need a required library, that is pandas I'm going to use and numpy I'm going to use. Here I am simply just want to show you like how you guys will get the data. So what you have to do, you have to simply copy this link, paste this link in the tab of Chrome, and you have to hit enter. You will directly reach to this data set, okay? And you have to simply click here. Once you will click, you will get archive file. So archive 7 zip I'm getting here. You have to go to downloads. I'm going to downloads and I'm getting here. One second, let me zoom it. Archive 7. You have to simply right click on this and you have to extract all the files from here. It will create a archive 7 kind of folder in the same directory, download directory, and you have to simply click extract. So you will get one more folder, which is archive 7. Once you will click in that, you will get salary data set. Now this salary data set, because I'm using Google Colab Sheet, so I will keep it in my Google Drive, okay? So what I did is I simply place it in Google Drive. So where is that? So you have to go there in the drive. So you simply mention here Google and you have to click here on drive section. This is drive. And then you have to create a folder. So I already created a folder, deep learning tutorial file. I already keep a data set here, which was salary data set, which I have used in the last session where I have only one feature and target. I will show you. This is that feature year of experience, and this is the target. And the data sample was also very low. There was around 32 data sample, 32, right? One second, let me check. It's not 32, it's starting from 0 and going up to 29. So 30 samples are there, okay? But the data set which I have just downloaded in my local machine is salary data set, which I already keep it here. So let me remove it so I can show you how to push the data here in your drive. So what you have to do is you have to simply right click here, okay? And you have to click on upload files or file upload. You have to simply go to download section, archive section, and this data set you have to click and select and hit on open. It will simply upload here. See, I'm getting data salary data.csv. This is my data set which I'm getting here in my drive. Now I can upload, I can upload this data in my drive, and I can also fetch it in my Google Colab sheet. Okay. So this is my drive folder. I will click on this. My drive you will get. I'll click on this. After that, I have to go to deep learning tutorial. So this one I'm talking about. See, here is a underscore here. I don't have underscore. So this is the only symbol using which I identify this. So once I will click on this, I will get salary data set. This is the data set which I am going to use. I just want to show you the same salary data set. Once you will click on this, you will get higher number of features. See, gender, education label, job title, year of experience, and salary. So salary is the target, means using this model, I will try to extract the salary providing any kind of experience. So let me click it again. So let's say if I'll provide like a male having bachelor degree, and I will not use this column, okay, job title, because job title are so much there in this data set. So I remove this, okay, because I cannot go with this job title and year of experience, okay. So this is very complex data because job title is a kind of parameter which I cannot one hot encode, like convert it into number, because I have to convert all the data into number before passing it to a model training. So I can convert this education level, because there are three kind of education level in this data set: bachelor degree, master degree, and PhD. Okay, not more than that. Okay, so there are three levels only: bachelor, master, and PhD. After that, if you will go to job title, in job title we have more than 150 kind of job titles. Okay, so that's why I removed this. I did not one hot and code this. Okay. And after that, I have year of experience. Now, think about it. This is he is a director. Okay, having 20 year of experience and getting around $200,000. All right, let's say. So this is a salary of a director. Okay, maybe he is a sales director. He is having 22 year of experience and getting 1,80,000 kind of salary. Okay, so this data totally depend on their uh, title, job title. Okay, suppose a person having 20 year of experience in color, okay, and another person having same experience of 20 year in director role. So director will get higher salary, but that clerk will get lower salary having more experience. So because I remove this data job title, the data will become a little bit complex, and to train a model in this data set is quite complicated as well. So the loss you will get always higher. I also show you why you get higher. Okay, all right, see here, he is a sales executive having 21 year of experience and getting $160,000, let's say. So he is having 21 year of experience, but the difference between a director salary and a sales executive salary is around $40,000 kind of gap. Okay, so that is a huge gap. All right, this is totally depend on the title, and I already removed this title because I don't want to one hot and code, because there are a lot of like more than 150 job title there, and our sample data samples are there in our file is around 300 something. Okay, so I cannot use it. Okay, I cannot use it. 370 five data set are there. Okay, here it is mentioning 376, but I know there are 375 kind of samples. And one more thing, there are two uh person kind of data set are like empty, there is nothing given, and that's why I remove those data. So 373 overall sample I have in this data set. Now I just wanna import it here. Okay, so I imported this file in my Google Colab sheet, and here is the path. So you guys have to simply click on this like a copy path. Okay, and what you have to do is you have to pass your path here after mentioning pd.read underscore csv, because this is a csv file, and a csv file always contain a csv extension with it. So here it is mentioned salary data.csv, and that's why I'm using underscore csv method to get this data by using pandas. Okay, and I stored it inside a variable called data. Okay, you can use any kind of variable here, it's totally up to you, but I use data. Okay, now I want to see the first five sample of the data. Okay, first five sample. This is first sample, okay? This is first sample. This is second sample. This is third sample, all right, and so on. So I have 5 samples, okay, and I just want to see the 5 sample just to understand like what kind of data I have. That's why this method introduced in pandas data.head. Let me zoom in so you guys can see it. Now I don't need this, so I'm simply hiding this, all right. Moving ahead, I also want to see the last 5 data samples. So in pandas, we have a tail kind of method there using which I can get last 5 samples of the data, right? So data.tail parenthesis will give me last 5 samples: 374, 373, 373, 72, 371, and 370. These people also having some salary, having some experience, job title, education label, gender, age, right? After that, if you will move like further, I just want to see the data as whole, right? I just want to see all the data at once. So it will simply giving me top of 5 data and last 5 data, right? And the 3 dots here you can see, right? So the 3 dots here will simply hide the data which you cannot see right now. Why it happened? Because suppose if you have 1 crore data samples over there, okay, so if you load that data, it keep loading, okay, it will keep loading for a long run, all right, and it will make your development slow, right? So to protect ourselves from such kind of loading kind of stuff and time, we or pandas generally do such kind of thing. Panda internally convert these thing into 3 dots, but all data are there in this data variable, okay. If you want to see this, you can simply mention your values, you will get the array. Okay, let me check once again. Yes, see, it is showing me in 2D array now, but again it hide all the data. So you guys will ask me, how can we see all the data? Let's say I am running a loop for I in uh length of this, and I'm converting it into range. Let's say it's a loop, simple for loop. If you guys didn't know about it, just go to my Python playlist. There I have explained everything from the scratch. All right. So I just want to see all the data. Okay. So I will use data dot values parenthesis, and I will mention there I, because I, it will give me, it will give me, this one will give me like the maximum length, okay, like 373 samples are there, right? So it will give me 373, which will start from 0. So it would look something like this to you guys. For I in a range 0 to 0 to 373, it will look something like this, okay. This value basically represent this one, all right. So don't get like panic to like what it is. So that's why I mentioned it here. And because this is my whole data, okay, I use the whole data here and I simply index each and every value, because this is a 2D array. So there a kind of thing I would like to show you that. One second. So let's say I have some sort of 2D, this is a 2D array, okay, because in the outermost we have 2 brackets, all right, and there we have one array, two array, three arrays are there separated by comma. So it is on 0th index, first, second. So I want to fetch data from this 2D array one by one, all right, and that's why I need some sort of some sort of operation, all right. So just to get all the data one by one, I'm using it just to show you like whether there are such kind of data or not, all right. Just to show you where whether there are multiple data available or not, just to print all the data, I just did that. So see, I'm getting all the data, okay, I'm getting all the data, okay. There are a lot of data, okay, 373, all right. See, there are a lot of data, I get all the data at once, okay, because I run a loop. But I just want to show you this. I'm not going to print it anymore. Let me use different shell because I want to show you the data. So data dot uh, so data is here. Okay, let me run this. You'll get all the data. So you can see it again. It is in the data frame form, which is the data type of pandas. Okay, so pandas represent your data something like this. If you'll write it inside a print function, it will give you a different kind of structure. You can see that. See, this is the structure it will provide you. All right, so don't use print. You have to simply mention your data. Okay, it will give you all the data points. Now data dot is null dot sum, what it is. So first of all, I would like to break it down. So let's say this is my data which you guys already have seen, right? So this is mentioning like 375 rows, means 375 samples are there and 6 columns. All right, so this is column. Okay, let me mark it. This is column, first column, second column, third column, fourth column, fifth column, sixth column. Okay, if you'll index them, this is on 0, 1, 2, 3, 4, and 5, and these are rows. Okay, these are rows. Okay, so this is first sample, second sample, third, fourth, fifth, and so on. All right, so these are my data samples. Now removing these all, so I have to simply show you like data is this, like which you are watching here. But I told you like right now I have 375 data samples, 375 rows. Okay, and 6 columns, but there are 2 columns which are empty. All right, so I have to remove those columns, and for that I have to use a kind of method, and that method is null. Is null will simply give you true. Okay. Is null will simply give you true for those values which are empty. All right. So let's see. Means here it will give you false. Here it will give you false. Here it will give you false. Means where their data available, it will give you false. But the data where but the slot where data is not available, it will simply give you true. So it will give you false everywhere. You guys can see like false is everywhere. So how we will detect? I will say no, this is not the right way. You have to use one more method there, sum parenthesis. Now what it will do? It will give you added value. Like in age, there are two value. In age, there are two value. Okay. In age column, there are two value. What is age column? This is age column. Okay, this is age column. So in this column from start to end, at least two values are empty. Empty means there are no value. Similarly in gender, means this is gender column and there are two value which are empty. Okay, similarly in education, job title, year of experience, and salary. That means out of 375 rows or samples, two data are empty. All right, so what do we have to do? We have to remove it, right? Because without removing, we cannot uh, we cannot train our model. So let's say this is that method using which we will drop that empty column or rows. Okay, so I'm not removing columns, I'm removing rows, right? So let's remove it. If you will mention data.drop NA, okay, it will only target those rows where data is missing. If there is one data is missing, it will simply remove all the rows. If there are two data missing in the same row, it will remove all the rows. So in any case, if any data or multiple data missing in a single row, it will simply remove that row. All right. This is the functionality of this drop NA. So I will run this and I will store the value inside a new variable because I have to do further operation on this and I have to train a model. So I need that variable data underscore filter further to train a model. So data underscore filter, when I'm using it, okay, I will get filtered data. If you want to see, let's show you. So right now you guys just see like 375 rows means 375 samples are there. But now, once you will run this, it will show you 373 rows are there, but 6 columns. So column not get affected, but rows get affected, right? 373 rows are there, right? So that means 2 rows were empty, and that's why we are not able to uh, get it now because I already removed it. So now I have a data filter. Okay. Data filter is a new variable where I stored all the filtered data, means after removing those two values. Okay. And now if you will run is null dot sum, it will give you 0. Okay. It will give you 0 in front of each column. These are column name: age, gender, education, job title, year of experience, salary. These all are uh, columns. All right. So in each column now there are none of the value which is empty right now. So that's why it is mentioning you 000 in front of each and every value. All right. So simply I just want to remove this because I want to show you the data. Okay. Or if you need, you guys can keep it here because I will provide this sheet. All right. So if you want to see, you can see like this. So now I am use one more variable here. Okay. Just to show you, like, this is the data where we have 373 rows now. Now what to do next? See, in gender we have categorical values like male female kind of value, which is not acceptable uh, in a deep learning model. Okay, means if you will try to create a deep learning model and try to train a model with this categorical data, which is male female, which is alphabetical value, not numerical value, so my model will simply deny it, will give me error. Okay, it will not train my model using this categorical data. So what I have to do, I have to convert them into number, and that number may be anything which is 0 or 1, just to represent a single category. Let's say I have male, female. Okay, or let's say transgender. All right, three kind of category. Okay, so if somebody will ask me, can you give them some specific mathematical number, I will say yes, I can give them, which is, I will call male by a number which is 0, I will call female by a number which is 1, and transgender by 2. Okay, so there are three values I will use to represent three different kind of community of a person, right? So similarly in this data set I will convert this male as 0, this female as 1, this male as again 0, female as 1. You know what, uh, I have to explore like how many categories are there. First of all, this is the most important part. Okay, so for that I have to do it using some pandas method. All right, I cannot do it manually. Let's say I have right now 373 data samples. Okay, it is easy to go through each and every sample one by one, but what if I have such kind of data sample? In that case, it is not feasible to go each and every row and find whether the categories are male, female, or whatever it is. So for that we have to generally rely on the methods. Okay, for that we use programming. Okay, if we have to do manual tasks, then programming is not beneficial. Just to automate the task we use programming, right? So let's do it. So first motive in this column is, first motive is to find out find out how many categories, all right, categories are there: male, female, or transgender. Okay, so because according to our common sense knowledge, we understand like there are two kind of or three kind of person: male, female, transgender. So what kind of data given in this column? Okay, I have to find it out, right? So let's go to the method again. So I have to use data filter, which is my data set name, the new name, data filter. I use a square bracket. Keep in mind, square bracket, you have to use square bracket, and you have to mention the column name, which is gender. All right. So I will use that gender inside a single quote. Okay. And I will mention dot values. Okay. Look what happened. I'm just removing this. Okay. If I will do this, I will get only gender column now. See, 373 rows are there, one column, which is gender. Okay. Now, if I want to get the category, see, I am not able to find out how many categories are there, male, female, or transgender, right? So I have to become very much sure before moving further, right? So for that, what I have to do, I will simply copy all the values here, which is simply representing a column, which I can see above here. See, so to get like how many unique values in that column, I have to do what? I have to use value count. Okay. So value count I will use, and it will, I'm sorry, you have to use parenthesis. This is a method. So it will simply give you count male and female. Two kind of people are there, and their sum is 373. Means if you will add 194 and 197, it will give you uh 373. See, let me do it again. So I'm going to use a simple operation. 9 4 13 1 9 1 10 7 1 and 3. See, so if you'll add them, you will get 373 rows. That means there are 373 rows, and we are also getting two kind of category, male and female, and their sum is also equal to 373. That means there are only two classes in a male section. So now I'm very much sure, like in my data set, there are male and female only, not a transgender. All right, let's move it. Let's go down. And this is my data filter dot column. See why I'm using this. I have to use it initially. Like it is just to see how many columns are there in my data set. So right now in my data set, I have age, gender, education label, job title, okay, year of experience, and salary. Okay, these are the columns, or you can say all the variables we have. We also used to term it as a variable sometimes. So we have six variables in my data set, which is data filter. Okay, if you want to see this, see age, gender, educational label, job title, year of experience, okay, year of experience, salary. Okay, so these are the columns. Now moving ahead, I don't know what happened. I think it's got disconnected anyhow. 1 second. All right. So again, again, I have to check like how many uh categories in education label. So in education label, we have three categories. Okay, bachelor, master, and PhD. I told you how we find it out, right? If you will again add 51, 98, 224, you will get all the you'll get the sum, which is equal to 373. Okay, so this is how we are detecting it. So this is our first motive, like how many categories are there, we have to detect it. Similarly, I detected the job title, like in job title, how many categories we have. So see, I told you now there are more than 150 rows, means 150 different categories. So their exact values 174 categories we have in our data set of the title. So that's why I didn't one hot and code them, because this is not beneficial, right? So moving ahead, I simply will remove this job title column, because 174 category is not a good choice, like to one hot and code and train the model. It will not give you better results. So the better option is to remove this. Okay, if you have billions of data, in that case you can use it. Okay, but I have 373 samples. I have 373 persons data, right? So this is not a beneficial kind of approach to one hot and code 174 rows or 174 title, okay, in 0 1 2 3 kind of number, right? So that's why I'm skipping this column. Right now I'm not skipping, but I will skip it later on. So see, here I'm skipping everything, what is required, what is not required. So once again, I just want to show you the data. So this is data underscore filter. Okay, it will give you all the data. Okay, now I just want to see the first five values. So I will say head. See, it is showing me only five samples, first five samples. So why I'm showing you this? So see, I just want to explain something here. I want to drop what I want to drop. I want to drop those column which is not important. So I already told you age is important. Age is very much important. If a person saying I have 10 year of experience, okay, so how I will believe on him. Let's say he born in 2000, okay, and right now it is 2024, all right, and a person is saying I have 10 year of experience in software development. That means he must completed his bachelor's in at the age of 14 year, which is not true. Okay, none of the person can complete his bachelor in 14 year. Maybe some exceptional would be there, but in general 14 year is not appropriate age where a person can complete his bachelor, all right, and join a company. Okay, because in India also after 18 you can work, all right. So age is a very important factor using which a person can be validated whether he has such kind of experience or not, right. So that's why age is a important feature we have, and that's in number, so that's important. Gender is also important. Sometimes what happened, let's say in Delhi, I'm in Delhi right now, and some person is in let's say Bangalore. Okay, okay, so let's say a girl live in Delhi with their family, okay, their family, and she is working here, okay, in Delhi itself. In Delhi itself, she is working, and some person offer this girl a job in Bangalore location, okay. So maybe her family member will say, don't go there, okay, because that's far from home and you're getting better salary here. Just for a little bit high, don't go there. So maybe this girl stop in Delhi. She continue their job in Delhi. She will not go to Bangalore, okay? So, gender also matters sometimes. They have to think, a person have to think about their family. Similarly, if you'll go for a married man, all right, these are all the part of analysis. I also created video in analysis. You guys have to simply go to their playlist, okay, just go to that playlist and you will definitely understand what I'm talking about. So if a married man settled with their family, their kids in Delhi, let's say, once again, okay, he is working in Delhi, and some of the person giving him opportunity in Bangalore again, okay, so he will not go there. Why? Because their family based out in Delhi, and everything like he buy land, he built his house, he has all kind of work in Delhi. So why he will go to Bangalore? Most of the cases, like in 30% of the cases, a person will stop to go to Bangalore. Okay, because he's settled there. Age is also a factor for this. Like if a person will become older, maybe he will not go there, okay, because he need family cares, right. So gender is also important in our data set to detect whether what kind of salary a person is actually looking for, and we can provide them. Okay, education label. Education is also important. If a person will say I'm 10th pass, all right, can you offer me a job of 160K? 160K. Okay, so I will say no. I cannot provide you 160K kind of salary. That's too much. Okay, I'm talking about dollars. Okay, so it's an annual salary. These are annual salary. Okay, in dollars. Okay, so education is also important. If you are very much educated, you will get higher salary. If you're not educated, you will get lower salary. Okay, job title is also one of the most important factor, right? But there are a lot of category we have, so I am going to skip this. I will not use this data in my training. Okay, year of experience important, like since how long you're working in the same profile, like as a director how long you're working, okay, as a software engineer how long you're working. So These are very much important. According to the year of experience, a person will provide the salary. This is the most important factor we have. Okay. So now, just want to conclude this. This column, age column, gender column, education, year of experience, and salary. These are important column, and I will simply pull these data, okay, and keep it here. So for that, I have to do some operation, and this is that operation. Now what it is, let's say, once again, I just want to show you. This is our data filter data set. So I use data filter data set. I use a function ilog. Again, if you don't know what is ilog, data analysis, okay, NumPy pandas, just go to my playlist. There I already created about it. All right. A lot of videos, like 44 or 45 videos maybe over there, okay, in data analysis section. So just go there, you'll get everything. So this is column. Column means you need all the rows. You don't want to skip any rows, okay? This is the column, comma, okay? This is for rows, okay? You need all the rows, that's why you mentioned column, okay? This is a square bracket, means an array. In that array, you have to pass. I told you, no, you can simply indicate them by indexes 0, 1, 2, 3, 4, and 5. So I need only those values which are important. So 0, 1, 2, I required. I don't require this. I need this. I need this. All right. So I will simply mention 0, 1, 2, 4, 5. I will skip 3. All right. And once I will run this, I will try to print it again. I run this. I store the value inside this variable. I print that variable and I'm getting the same out. I'm not getting here. See, age, gender, educational label, year of experience, salary, but I'm not getting job title. See, job title is missing here. So now I'm cleaning the screen. So now this is the data what I'm getting, and I will use this data to train my model. But before that, I have to work on few more things, like what I have to do. The second approach, I have to one hot encode them, like male one, female, male 0, female 1, male 0, female 1, some sort of categorical data. I will convert them into numbers using a map function. I will show you. Similarly, bachelor, master, PhD, I will convert them into number. So wherever I will get bachelor in this row, I will simply put it there, put 0 there. If I will get master, I will get 1. If I will, let's say, mention PhD somewhere in the column, I will simply mention 2 there, okay, instead of PhD, okay? So I have to do this. This is called one hot encoding, okay? And next, I will do one hot encoding, okay? So using map function, I will one hot encode them, not using TensorFlow one hot function. So see how I can one hot encode. So in data filter, this is my data filter data, okay? I name them with data filter. Data filter, I will use first gender column. Gender column where I have two categories, male and female. I already show you on the top, right? See, male and female. There are two columns, male and female. There are two kind of values we have in gender column. So data filter, I will use gender column. Dot map I will use. I will use parenthesis because map is a method. So parenthesis. And inside that parenthesis, I will use a dictionary. This is a dictionary, curly bracket, where I will use key like my classes, like male and female. These are keys. This is first key, this is second key. I will give first key 0, second key 1 kind of value. So wherever in this column, in gender column, I will get male, it will simply put 0 there. If in the first, in the gender column, it will get female, it will simply place there 1. Okay, and remove the male female part. Okay, so see, after running this, I stored the same data into the same column, and that's why I assigned it to the same column, because I make changes in this column only, and that's why I'm mentioning here data filter gender. Okay, so when I'm running this data filter, I'm getting male female right now because it's not working. I think the shell breakdown, okay, because simply disappeared. Okay, so I have to run from the start. So let me run it from here. I'm running everything from the top. Yeah, see, gender 010101 I'm getting. Okay. And one more thing, guys. This is the kind of warning. This is not an error. Okay. This is a warning. Okay. So it will make changes, but it is giving you warning. It is saying don't assign like this. Okay. Don't assign like this. If you'll assign like this, maybe in future you will get some sort of error. Okay. So don't use this equal and this variable. It is just suggesting that. All right. Moving ahead. Now I want to one hot and encode to education level. Same I did. I mentioned data filter. Okay. I use education label colon and dot map function I use. I use parenthesis and curly bracket. Inside curly bracket, yes, one more thing, guys. Bachelor comma S. This is mentioned. Okay. See. So these all are case sensitive. Always remember this thing. Like B is capital in bachelor's and a comma is there after R and S. Okay. So you have to simply mention there bachelor's apostrophe S. All right. Similarly, master apostrophe S, PhD. Okay. It should not be like this. If you will mention something like this, it will be an error. The letter should be same as it is mentioned here in the doc. Okay. In the data. Okay. Run it. It is again giving me warning. It is saying you assigned this all value to the same column. So maybe in future you will get error, but for now it make changes. Okay. See, I'm getting 0, 1, 2, 0, 1 and 3 dots. It's hidden. And year of experience there and salary. I'm getting everything. Okay. Now this data which I picked initially is in the form of number only. So now I can train my model. Okay. From here, you can train your model. But again, what you have to do? You have to break this data into a two part, feature and target. Again, machine learning or deep learning, important concept, feature and target, feature and target. You can do that. You can train your model directly. Okay. But you know what? Recommendation to a machine learning or deep learning engineer is most important. Most important. Scale your data. Scale your data. So feature and target we have, right? These are our feature. And this is our target. This is Y. This is X. Feature represented by X. Target represented by Y. Feature and target. So you guys will say, can we not train this model directly? I will say, yes, you can train the model, but you will not get appropriate result. You will not get optimized result. Okay. Your model will not reach to global minima easily. What is global minima? So loss will not get reduced easily. Okay. So what is the recommendation? Recommendation is scale your data before training your model. Before training your model. This is the recommendation. So first thing is what? Scale the data. And second thing is what? Then use to train your model. Okay. Now there is one more twist. Before training your model, let's say you have 373 data samples. So recommendation is before training your model means after doing this at second label. Okay. What you have to do? Split the data. Split the data into two parts. Into two parts. The first part will be training data, and the second part testing data. So there are two kind of part we have: training data and testing data. Why you are creating training data, testing data? Maybe anybody will ask you. So think about it. Let's say I train a model. Okay, I train a model. This is my model. Okay, let me create like a robo. This is like a robo. Okay, I give him my all data. I tell this robo, just see my all data. Okay, their feature and target. Okay, and when I will ask him, tell me how many year of experience, I will ask him like a person having age 10. Okay, let's no, not age 10, age 40, gender male. So male used to represent by 0. See, male is 0. Okay, and education label. One second, guys. Education label is, let's say, master. Okay, masters. So master represented by uh that's a bachelor, master represented by, I guess, 1. Okay, so 1. After that, I will say he has 10 year of experience. 10 year of experience. Okay, this age is overall age. Okay, like a person have is 40 year of old, and this 10 is like he has 10 year of experience. Okay, so this is experience. I will provide this data to my model, and I will ask what should be the salary. What should be the salary? Okay, then my model will say their salary, predicting them. Okay, this is simple. But what if this model memorize all the data? In that case, how will you test? So for that, we do not show each and every data to our model. Means, let's say I have 373 data samples, right? So I will only provide, let's say, 300 samples. I will only provide 300 samples. They are training and testing. Sorry, they are feature and target both. Okay, I will provide 300 samples. It will see. And I will train my model. Okay, it will train it. Okay, my model will train on the given data. Okay, and try to find out a pattern. So in future, whatever data my model have not seen, that 75 samples out of 370, oh sorry, 373 samples out of 300. So let's say my model haven't seen that 73 samples. Okay, so that 73 samples, if I will ask to my model, tell me what should be the salary of these 73 samples, it will simply give me a approximate kind of result. Okay, after prediction. Okay, so I can test it. How? By asking on unseen data, which my model cannot see so far. Okay, so I use this samples to validate whether my model memorize the thing or learn the thing while training it. While training it, it creates some pattern, it finds some pattern. So if any kind of question, if I will ask, it will answer me, or it memorize the stuff. That's why we have to split the data into training and testing part, just to protect our model to memorize the stuff. Okay. All right. Moving ahead, this is our data filter. Okay. Means again, one hot and coded data. Now breaking down the data uh, three into two parts, feature and target. See, Now, feature and target. I will create feature and target. Second, I will scale the data. Third, break the data into training and testing part. Fourth, train a model. This is the final stage. Okay, we have to reach up to here. So now I'm going to start it from here. Okay, let's say I'm creating my feature. So what is this now? See, I just show you like we have we have 0, 1, 2, 3, 4. 4 indexes, 4 columns. All right. Python also do minus indexing. -1, -2, -3, -4, and -5. So these are my feature. To get this data, what I have to do? So data filter dot ilog, and I will mention here I need all the rows. Okay, but I can mention something like this. I need 0, 1, 2, 3. Okay, these column. Okay, or I can mention like, okay, this should be in parenthesis. Okay, I can mention the same stuff like this. ilog. Okay, parenthesis, colon, colon, comma, colon, -1. So this -1 means I will, this -1 means it will not consider this, except this from start up to this place. It will contain everything. Okay, this is that part. This column means I need all the rows, but I need which column? Except the last one. Okay, I need everything. So these are the columns. Okay, I'm erasing this again. I know this is quite complicated, guys, but now you are learning deep learning, right? So just please use to it. All right, so ilog I have used there. This is feature, and I use to store the feature into X variable, and I print this X, and see I'm not getting salary now, but I'm getting all the rows, 373 rows, 4 columns. Okay. Similarly, I need target, which is Y. Okay. So Y, see, one more thing, guys, I will tell you later on. This is my Y. Okay. I need last column only. So I will simply mention -1 there. Okay. That's the last column. Okay. So I'll get only salary part. Okay. I already teach about these kind of stuff in my data analytics NumPy pandas videos. So it is also like a 373 salary we have. Okay. Now I'm scaling the data. Scaling the data. Using sklearn, there is a pre-processing module. Inside that I have min-max scaler. Min-max scaler is a class. So I create object like SC. Okay. And using SC, I fit my and transform my X. X is what? My feature. These are my feature. These are X. All right. I pass this all to this SC variable, which is a object of a class. Class name is min-max scaler, and this is object of this that min-max scaler. And I'm using sc.fit underscore transform, passing my variable X, and I'm storing that value inside X underscore SC because I have to use it further, right? So X underscore SC, I mentioned here. C, x underscore SC. Once you will run this, you will get your scaled value. Okay, this is my scaled value. Okay, I guess it's again disconnected. Let me run it from here, whether it is working or not. Yes, it is working. Okay, okay. So see, I'm getting here scaled value. Okay, now in each column and each value, you guys can see here, each value, okay, is between a 0 and 1. Is between 0 and 1. Okay, 0 or 1 are also included in this. So in this column, my min-max scaler basically find the maximum value and minimum value. Okay, and it simply divided. Okay, such kind of thing happen. Okay, similarly in this, see, this is 0 1 0 1 0 1. So it's simply divided by maximum value. Maximum value is what? 1. Minimum value was what? 0. So the same value it is appearing here. Similarly in this case, 0 0 0.5 1. Okay, so maximum value is what? 2, and minimum value is 1. Okay, similarly this is my year of experience, so it simply calculate minimum value and maximum value. Means in each column, min max scalar find minimum value, maximum value, minimum value, maximum value, minimum value, maximum value in each case, and it simply divide all the values of that column with that min max values. Okay, and convert the all values between 0 and 1. Okay, so this is how min-max scalar work. If you want to know about more, you can see my machine learning playlist. There I also taught about it in detail. Okay. Moving ahead, I'm just cleaning it. Moving ahead, I am breaking down the data into two parts. Train test means my X. There are 373 rows, right? So in X, I have features. So X divided into two parts. Okay, X divided into two part, X train and X test. X train and X test. Okay, Y train, my target, my salary only. Y train and Y test. Okay, so I use X underscore SC, the scale data. X underscore SC. Always keep this thing in mind. Always scale your feature, never scale your target. Okay. So X underscore SC, that's my feature. I passed it here. Then Y is my target. Okay. I pass it here because feature and target. Let's say in X train, I have 200 samples. Then the Y train should also have 200 their target, because 200 sample have 200 target, right? So that's why we have to pass X, Y both here. Okay. And train size. Now, suppose, again, I'm showing you the whole scenario. Just for example. Okay. This is my X. This is my Y. Okay. This is my feature 1, feature 2, feature 3, feature 4. This is my target 1, target 2, target 3, target 4. Now, I want to split the data into training and testing. Okay. If I will ask you, like, in which ratio you want to break them down, I will say 75 25. That means 75% of data will go in training and 25% of data go in testing. Okay. So these are 75% of training data and this is testing data. Now you guys have to understand this also. X train and X test. The first X The first X train is that 75% of training data. This is X train. This is X test. Similarly, this is Y train, and this is Y test. Keep this thing in mind. The same thing is happening here. Okay, always remember the sequence. Always people make mistake in the sequence. Okay, people always make mistake in the sequence. Okay, so keep sequence in mind. X train, X test, Y train, Y test. Okay, now creating a neural network model after doing this. Okay, so this is my final approach. I'm just erasing all the screen. All right, so creating a model using neural network. Okay, if you guys want to see, is X train there? I will show you. Yes, X train is there. What is the shape of the X train? What is the shape of the X train? Shape means how many rows are there. So there are 261 rows. Okay, 0.7 means 70% of data is in training size. Okay, means this is 70%. This is about 70% data into training, and remaining are in testing. Okay, 30% data is in testing. All right, similarly, if you want to see their target, means X Y train. Okay, this is the target, so this is Y train, only salary. See, only salary. Okay, so if you want to find the shape, it will also give you 261. See, okay, so 261 feature having 261 target, X train, Y train. Similarly, X test having some sort of values. Let me show you that also. X test. This is X test. All the features of X test. Now I want to see the shape. Where is that? I think it goes here. Okay. So X test having 112 uh, samples. Okay. Whereas Y test also have the same shape. Okay. See. Now if you will add this and this, you will get 373. Add them, you will get that 373. Okay, so our data gets split into two parts, train test part. Okay, now create a neural network model. Okay, I was doing some experiment on this because it takes a lot of time. Okay, so initially, again, everything is same like previous one. Okay, in last class, what I have trained a model. I only want to show you like MAE you use in front of loss. MAE, if you want to see, you can use it in matrix. Okay, everything is same like the previous one. Okay, everything is same. Okay, so if you will train a model, you will not get a optimized value. You will not get a better result. You will not get a better model. See, losses are very high, very high. Okay, not acceptable. Okay, so what I did, I enhanced the model. I made it on 1000 epoch. I run for 1000 epoch, and still I didn't get the better result. Why I didn't get the better result? Because I do not have job title. I told you now, if a person having clerk experience, okay, if a person having clerk experience, this is a person, he is a clerk, okay, since 20 years, okay, he has 20 years of experience. He is getting, let's say, 140K dollar, and a person, another person having director kind of experience, and he is also of 20 years, he will charge 200K. The gap between these two is 60K. Okay, so title is very much important, but in my data set there are 373 rows, 373 samples, out of which 171 are the title. So to one hot encode, this thing was not beneficial. And that's why I didn't want to import them. Now, everything is same here. This is a simple neural network. You have to use TF-Keras, okay? You have to simply mention your neurons. This is feature, okay? This is feature, okay? If you wanna see what I did it here, okay, I can show you. X underscore train dot shape, okay? If I will pass the very first sample, it will give me 4. 4 means I need 4 neurons. This is simply representing your outermost neuron. I will draw this for you. See, suppose this is my model. So this is output layer. And this is represented by X train dot shape 1, which is represented here. This is your outermost layer, okay? After that, I created first hidden layer having 1400 neurons. How many neurons are there? 1400 neurons are there. Okay. This is my first layer. Then I create one more layer. Having 600 neurons. This second hidden layer contains 600 neurons. I created one more layer, third layer, having 300 neurons. 300 neurons. After that, I created one more layer. It's a collection of layer because I did a lot of hidden trial, and then I find the conclusion like what should I do, and that's why I created such a huge number of network, 150 neurons. Okay, I created on this is my first hidden layer, second hidden layer, third hidden layer, fourth hidden layer. This is my first hidden layer, second hidden layer, third hidden layer, fourth hidden layer, 150. Fifth hidden layer having 75, sixth hidden layer having 30. So this is my fifth hidden layer where I have 75 neurons. This is sixth having 30 neuron, having 30 neurons, sixth layer. And this is one neuron at outer layer. Okay. Now all the 4 feature pass at once and it will go through each and every neuron. Okay. It will again pass each and every neuron and it will finally give me a single output, like what should the salary of the person. There I use activation function ReLU. ReLU give me a better result. Okay. I also tried with Licky ReLU, but I didn't get better result. Okay. I used 10H, but I didn't get better result. Okay. You have to memorize everything. What activation function we have. Okay. So I use everything. Okay. So this is my outer layer. Okay. Keep this thing in mind. This is my input layer. Input layer. This only is your input layer. And this is your first hidden layer. Okay. First hidden layer. Always people get confused like whether it is a hidden layer or input layer. So most of the people get confused. So only this part is your input layer. After that, the neuron which is manually defined there are the first hidden layer. Okay. Activation function ReLU in each neurons. In each neuron, you have activation function which is ReLU. Similarly, in each layer, you are mentioning neurons and activation function. Okay. So this is your network which you have created. This is what your neural network you have created. This is only network. This is not complete model. Okay. Now I'm cleaning this. This is your model compilation. Now you have to compile your model with some additional parameter which is called optimizer. I'm using an atom. Okay. I also use RMS prop. Okay. But I didn't get better result. I use NDAM. Okay. I use RMS prop. Okay. So I use Atom there also. Okay. I didn't get better result. I use mean absolute error. MSE? MSE. You have to use something like this here. Mean absolute, sorry, M MAE, mean absolute error. You have to use mean absolute error here. It is a kind of function which you have to pull from tf.keras.loss.absolute error. You can see absolute error, okay, mean absolute error. So you have to mention in the matrices also, like MAE, okay. And then you have to fit your X train, Y train. It will use your X train, 261 sample of X train, and Y train having 261 target. Okay. So these data I'm passing basically here to train my model. Now batch size. Here we have 261 samples. So 10 batch size will create it. So how many batch size would be there? So 27 batch size would be there. Because if you will split them, you will get 27 number. Okay, in 27 time with 10 samples, you if you start splitting it, you will get 27 batches. Okay, so this is a batch size. Epoch. After running each and every sample, okay, after going through each and every batches at once, like 261 sample, it will go at once. Okay, it will train everything. It will train every data samples. Then again it will use to train it. 261 again it will train. Okay, like whatever mistake it will make in the initial approach, it will try to rectify that. So this is first epoch, this is second epoch, and similarly we have 1000 epoch. It means it will take 261 sample 1000 time, and it will retrain on the basis of previous result. It will give you previous loss, it will give you previous loss, it will give you previous loss in each epoch. Okay, so to modify the previous loss, it will again retrain the model. Okay, and this is what, this is validation data. The X test and Y test, 71 samples you have kept. X test, no, not 71, I guess it is 112 samples. X test and Y test, 112 samples were there, okay, which were for testing. So I pass X test and Y test. So in each epoch, means once it's trained first epoch, it also calculate like what is the validation score and validation testing score and training score, both. Okay, means at that moment only it's try to calculate. Okay, because it is training on this data set. This is for testing at the same moment. In first epoch, it trained 261 sample, then it also picks some values from this data samples and calculate the validation score. Okay, so this is how the neural network basically work in regression. This is for regression. Okay, and see, I will show you. I'm getting loss 1,26,9. Okay, this is a huge loss. See, I'm getting validation is validation loss. This is val loss. Val loss means validation loss. Val MAE. Okay, so I'm getting validation loss here. Validation loss. Okay, and I'm getting model loss. Okay, the same time I'm getting validation loss. See, I'm getting here huge training loss, but testing loss is lower. This is testing loss. Validation loss is also known as testing loss. This is again validation training loss. Okay, which is 15,481. See, it is reducing on each epoch, right? Similarly, this one is also reducing. Okay, so it reduces. I run this one. See, I told you not 27 batches it will create. Remember, 271 samples having 10 batches each, it will give you 27 batches. So it create 27 batches each time, and it training each and every batches. Okay, and it will go up to 1000. It will try to reduce the loss, but at a moment it goes like 9912 kind of loss, which is a minimum, I guess. 992. See, this is the minimum, 9611. But I'm not getting better result. Okay. This is very high loss. Okay, I cannot deploy this model on training. I need more data. Okay, I need more data because 373 data sample, oh sorry, 261 data sample for training is not sufficient. So what I have to do, I need more and more data. Okay, so here the most required form, the most important thing is here, the most important thing is data. I need data. Okay, if I do not have data, the result would be same. See, 9212 is the minimum loss I'm getting at 1000 epoch. Okay, which is too much. We do not train our model for so long. Okay, it happened, but in very rare case. Okay, and see, I'm getting validation loss much. Okay, so first I need data, then we do another, then we implement another parameter to reduce the losses. So this is the overall approach to train our regression model. So this is all about. So once again, I just want to conclude, like if you will train some sort of model, let me scroll up. It's too much. Okay, let me tell you the thing. If you want to use loss like MAE, mean absolute error. If you want to use loss like MAE, mean absolute error, you have to use something like this. Okay, this is the only thing I want to show you, and for that I train such a model. It become very long, I know, but this is very much important to understand, like how the batches become, like what is this 27, okay, what is this 1000. So 1000 is this 27. I told you like 271 samples, split them into 10 batches. Okay, it will give you like 27 batches. Okay, so you guys have to understand, you have to understand like loss, what is loss. So in each epoch it generating some loss of overall 270, sorry, 27 batches. Okay, and it is that loss. Okay, 27 batches loss, okay, of training, and this is the 27 batches loss of testing. Okay, it's not like that 27 batches, but yes, it is a testing score. Okay, you can say that would be more appropriate in this case. So guys, this is all for this videos. Okay, so guys, I would request you to go through this video again and again, because I know this is very much complicated. I do not code line by line. I can do that, but it will take a lot of time. Okay. So I first try to code initially, and I just thought to make you understand like what's going on in each steps. Okay, how it works. Okay. So I would request you to go through this video again and again until you understand. Okay. And if you are getting any kind of problem, comment me. I will reply on that comment. If required, I will also create video on that. So thank you guys. Thank you for watching this channel. Please do like, share, subscribe, share with your friend, families, and thank you. Have a nice day. Keep learning.